Approximately 13.8 billion years ago, the entirety of the universe originated from a single point in space, a concept famously termed the Big Bang. Widely acknowledged as the prevailing narrative for the genesis of our universe, this theory gained prominence as scientists noticed the continuous movement of every galaxy away from our vantage point. This observation led to the hypothesis that at a specific moment in the past, all matter and energy were compressed into an incredibly dense location known as a singularity. Notably, this singularity was characterized by intense heat. The formulation of the Big Bang theory has been crucial in shaping our understanding of the cosmic origins, offering a compelling explanation for the expansion and evolution of the universe. Welcome to my channel. Before starting, don't forget to like and subscribe to our channel for more future updates. So, let's start. Other evidence of the Big Bang is something known as cosmic microwave background, radioactive remnants from the early days of our universe, remnants that you can only see with the help of a telescope. But what if we have this all wrong? What if the universe didn't start like this? What else were we wrong about? This is What If, and here's what would happen if everything you knew about the universe is wrong. Okay, so you know that our universe is continually expanding outward, so you might assume that it would likely continue expanding forever. Well, this could be true, and this is why the most widely accepted theory involves the universe doing just that. It's called the Big Freeze, and what's really cool about this is a mysterious and invisible force that makes the universe expand. It's called dark energy, and it makes up 69% of the universe's mass. Another 26% of it is made of dark matter, and only 5% of the universe is plain old ordinary matter. If all this material originated from one point and just kept expanding, eventually, all this heat and energy would be very, very spread out. At a certain point, everything would be so far away from each other that the entire universe would reach a ridiculously frigid temperature. Absolute zero. Absolute zero is the lowest temperature possible. It translates into 0 Kelvin, or, if you prefer a more familiar temperature scale, minus 273 degrees Celsius. By the time the universe reaches this super low temperature, you wouldn't be able to see any distant galaxies from your vantage point in the Milky Way. Don't worry though, that would be at least a couple of trillion years from now. That's just one theory. It's also possible that the death of the universe will be the exact opposite of this. Instead of expanding forever, the universe could shrink back together. Time for the big crunch. All of the matter in the universe taken as a whole has an unimaginable amount of gravity. It might be enough gravitational force to battle the mysterious dark energy and win. If this big crunch were to happen, the universe would start to contract in on itself. Galaxy clusters far away would merge. Eventually, stars and planets in our own galactic neighborhood would clump together too, and this increasing density would heat up the whole universe. All that cosmic microwave background radiation from the Big Bang would get so heated that it would be hotter than stars. We're talking 5,000 degrees Celsius hot. The universe would become a scorching, chaotic mess. As temperatures continued to rise and more mass got crashed into a teeny-tiny region, atoms would start to break apart. The universe would be turning into the densest black hole possible. While that would certainly be the end of the universe as we know it, it might just be the beginning of a new one, and that would be proof that our universe is much, much older than we thought. The universe may have formed itself over and over again in this violent cycle of contraction and expansion. You wouldn't have the slightest chance of surviving to witness this epic event firsthand. No one would. So for now, all of this is just an end-of-times theory, and it has a big name, the Big Bounce. It suggests that the universe expands and contracts all the time, just like a lung that breathes in and out, only in slow motion and not just once or twice. According to this theory, there may have been billions, trillions, or even an infinite number of universes both before and after ours. Each time the universe reforms, it could create completely different laws of physics. This would create all kinds of strange possibilities. There could be universes with no life, no stars, and not even an atom in sight. Now, this is all pretty wild, and it gets wilder from here. Some scientists debate that everything we know about our universe is wrong. What we know about the cosmos is based on what we can see and study in our galactic neighborhood. Then we assume that it works like that everywhere else in the universe. The idea is old, and it's called the cosmological principle. But we may have been wrong all along. It could be that the way our Milky Way galaxy moves through the universe is distorting our data. I mean, we've never had any hard evidence to confirm our theories, so there's no way of seeing the bigger picture from where we stand. This is where you could be starting to doubt whether any of this is real to begin with. Surely, our universe, the one we can see, must exist, right? Well, not so fast. You have quantum mechanics to thank for what I'm going to tell you next. Scientists who study quantum mechanics theorize about the nature of the universe on an atomic level. According to some scholars in this field, the universe must be one of two things, real or local. Bear with me here. I know this can be mind-numbing. The concept of the reality of the universe is explored through the lens of quantum physics, proposing two intriguing possibilities. If the universe is considered real, it implies that it possesses inherent properties, such as color and mass, that persist regardless of observation. Drawing a parallel with a red ball, if it is real, its redness exists independently of anyone looking at it. Conversely, the universe might be perceived as local, implying its existence is contingent upon our observation through telescopes. In this scenario, akin to the red ball having an indeterminate color without an observer, the universe's characteristics may only manifest when we actively observe it. Quantum physics posits this dichotomy, suggesting that the universe can be either real or local, but not both. The challenge arises from the vastness of the universe, potentially being infinite, and our telescopic limitations prevent comprehensive observation. Consequently, certainty about the actual nature of the universe becomes elusive, adding a layer of complexity to our understanding of reality and existence. This is it for today's video. What do you think of our video? Feel free to share your thoughts in the comment section below. Don't forget to like and subscribe to our channel for more future updates. Thanks for watching.